I'm Patty Simpson with Simpson Math. In this series of lectures, we are talking about parent functions. In this particular video, we're going to look at the parent function of a cubed root function. So let me give you some examples of cubed root functions. Here is an example of a cubed root function. And in function notation, here's another example of a cubed root function. Notice that in each one of these, we have the x underneath the radical with the index of 3 here. So under a cubed root, and that's what makes this a cubed root function. So the simplest form of a cubed root function is just y equals the cubed root of x. Or in function notation, f of x equals the cubed root of x. Now we're going to graph this today, and so when we get ready to graph it, we're going to plug in values for x and find some values for y, just as we've been doing with our other functions. And in the past, when I've done it, every time I've used the values -2, -1, 0, 1, and 2. But let's think about for a minute this value of -2. If I try to find the cubed root of -2, there is a number that I can multiply by itself 3 times to get -2, but it's not a pretty number. And so I'd like to find some numbers to plug in for x that would give me pretty outcomes for my graphing purposes. And we've already done some cubics where we multiplied numbers by themselves 3 times to get an output. This time, what I want to do is use that -8 as my input. And the cubed root then of -8, well, I'm looking for something that I multiplied by itself 3 times that gives me -8. And -2 is that value that I multiplied by itself 3 times to get the -8. So the cubed root of -8 is -2. Then, looking again here, my output when I multiplied -1 times itself 3 times, then I got the output was -1. I'm going to use that output here as my input. And the cubed root of -1 is -1, because -1 times -1 times -1 gives me that -1. So here my input and then my output is the cubed root of that. 0 is a nice one too. When I take the cubed root of 0, the output is 0. 0 times 0 times 0 gives me 0. 1 is a nice perfect cube. 1 times 1 times 1 is 1. And then for my 5th value, I'm going to use 8. That output that we had here becomes my input here. And the cubed root of 8 is equal to just 2, because 2 times 2 times 2 equals 8. So this gives me 5 values that I can now graph on my function. There are numbers in between here for x. I can put in any real number for x, and I'll get out a real number for y. But these are just 5 pretty outcomes that I can graph. Notice that what was my input and my output in my cubic function swaps around and becomes my input and my output for my cubed root function. We're going to learn later about inverse functions, and that's going to be one of the characteristics of those inverse functions. Let me graph these 5 points of the cubed root function on this graph. Let me do it in blue here. So I have -8, -2, 5, 6, 7, 8, -2, -1, -1, 0, 0, 1, 1, and 5, 6, 7, 8, 2. So this blue graph is my cubed root function. There's the cubed root function. Now, to help me remember which one is which, is the, in this case, my cubic function, the third street or the cubic function goes up and down just like the exponent is up on top, whereas the cubed root function, the 3 is on the side, and so this graph kind of lays on its side, so that we have the cubed root function. And there's the apparent function of our cubed root function. Thanks for watching.